Alright, so for those who are listening on the recording, this was a revision seminar for IFM. We've got a couple of people here, and the first thing they've asked for today is to have a chat about this exam question, which is question 4 in the 2012 Functions and Annuities part of the exam. And it says, explain why the polynomial g of x, which is equal to x cubed plus 2x squared plus minus 2, has a 0 between x equals minus 1 and x equals plus 1. Apply the bisection method 4 times to find an approximation for this 0. That is, if x1 equals 0, the first approximation, find x4. Okay, so there's a lot of terminology in that. We need to understand what it all means. So firstly, there's the terminology of having a 0, which would mean having an x that makes g of x comes out to 0. So let me just write it down. So g of x was x cubed plus 2x squared minus 2. And it's supposed to have a 0 between x equals 1 and x equals minus 1, right? I'll probably put them around the wrong way, but it'll do. That's what we're aiming to show. Oh, that's a bit fuzzy, isn't it? Sorry. That's a bit better. Okay, let me just check if I've copied it down right. X cubed plus 2x squared minus 2. Okay, so when we say a 0 of a function, so a 0 is a value of x so that g of x comes out to 0. That's what a 0 is. So it would be one of the solutions to that. Now, they're not asking us to solve that directly. They're just asking us to show that there is a 0 between x equals 1 and x equals minus 1. So if I think about what we've been told in the notes, as we did the lectures, we learned about how functions work in terms of their zeros, and a 0 would be a place where it crosses the x-axis as well. So it would be one of the x-intercepts. And we know that a function, if it's continuous, if it's below the x-axis somewhere and above the x-axis somewhere else, then somewhere in the middle it has to cross the x-axis. So what I'm going to do is I'm going to figure out what g of 1 and g of minus 1 is, because that's the only information I've been told, and we'll see what happens then. So g of 1 is 1 cubed plus 2 times 1 squared minus 2. So we have 1 plus 2 minus 2, which is 1. And g of minus 1 is minus 1 cubed plus 2 times minus 1 squared minus 2. Now minus 1 cubed is minus 1, minus 1 squared is 2, and minus 2 is minus 2. So that's negative 1. Now it's a coincidence that they came out to the same answer that we put in. Most of the time it would come out to something else. So it'd be really rare for a function to put 1 in and get 1 out, and put minus 1 in and get minus 1 out. Normally there'd be other numbers. But what we can notice is that g of minus 1 is negative and g of plus 1 is positive. And so therefore every value between minus 1 and 1 has to be covered between x equals minus 1 and 1. So in terms of a picture, there's minus 1 and there's plus 1, and my function is minus 1 here, y equals minus 1, g equals minus 1, and plus 1 here. And so my function has to go from here to here, so it must cross the x-axis somewhere in between. And that's called the intermediate value theorem. So we can just say in our working, not that we don't know what the function does in between. It could cross multiple times. So we don't know where it is, so I'll just do it as a dotted line, but we know it has to cross somewhere. So we can say that by the intermediate value theorem, and you are allowed to just say IVT, g of x must be equal to 0 for some x between x equals -1 and x equals 1 because of the intermediate value theorem, because one of them is below 0 and the other one's above 0. Technically, the intermediate value theorem says that every possible y value between here and here has to be covered somewhere. So it has to be able to be equal to a half and minus a half and 0.3 as well, because they're all between here and here. But we're focusing in particular on y equals 0. Okay, so that's part A. Oh, no, not all of it. So the next part of the problem, so that's the first sentence in our question. So I've just make sure I've done that. Explain why that polynomial has a 0 between there and there. I have a feeling that I should probably give a better reason, probably saying that since g of -1 is less than 0 and g of +1 is more than 0. That's important too. Just to explicitly point that out. I know it should be obvious, but it just gives all the information. So because g of -1 is less than 0 and g of +1 is more than 0, it must be 0 somewhere in between by the intermediate value theorem. So grammatically I could put that sentence in a different order. If I wanted, I could start with this and then say those, and that would work too. But this works fine. Okay, so the next part of the question was apply the bisection method 4 times to find an approximation for this 0. Okay, so they're not saying to find an approximation for 0, they're finding approximation for the 0 that we were just talking about, the x that makes it come out to 0. And so that means that if x1 equals 0 is the first approximation, find x4. Okay? So we're supposed to say, now find approximation Okay, so that means we need to know how the bisection method works. The bisection method means what we'll do is we'll keep cutting the interval in half and then making a decision on which side that 0 is in. So I like to draw a diagram to help me do this. Okay, I'm going to draw a picture here. I might have to zoom in as I go. But I do know that g of 1 is positive, because it came out as +1, and g of -1 was negative. Okay. So the first step is to find one of those intervals, and then we divide it in 2, and that makes my 0, and this one will be my x1. That's what they're saying. Okay. So let me just see, there's 3 steps, or possibly 3, I have to do it. So we need to calculate the value of the function at both at this point here, and then we need to look at what we've got and decide which interval it's in, and then divide that interval in half. Okay, so there's 3 steps. So 3 steps which we keep repeating. Calculate the function, choose the next interval, and then calculate the midpoint. Okay, that's the 3 steps we're going to do, and we're going to keep repeating them, and we're going to have to do that until we get to x4. So we've already done this first step, to calculate the function value at each of these, which we did. Then we chose the next interval, which was the interval we currently have, and then we calculated the midpoint, which was 0. And so now we're going to do that again. Okay, so I need to figure out what f of x1 is. So f of 0 is 0 cubed plus 2 times 0 squared minus 2, which is negative 2. So it's negative. So I'm just going to add that to my picture. It's negative here. Okay? And so since it goes, these are both negative, I can't be certain that it actually crosses the x-axis here. It might, but I can't be sure. But I can be sure that it crosses the x-axis here because it goes from negative to positive on this zone here. So the next interval is from 0 to 1. So I've done my calculation. So the next interval is from 0 to 1. And so therefore x2 will be the midpoint of that, which will be a half, because half is halfway between here and here. Like that. And so now, I'm going to have to keep changing colours as I go. I should do it in rainbow order then. That's the next interval we're going to look at. And we need to figure, that's the next interval we're going to look at. And we need to figure out whether it's positive or negative at that spot. Okay, so I'm going to need to figure out what f of a half is, and I might start using decimals because this is the best plan actually. Because we're doing an approximation, it's okay to use decimals, so I'm going to use 0.5 instead of a half, because it's designed to be an approximation. So f of 0.5 would be 0.5 cubed plus 2 times 0.5 squared, is it squared? Yes, minus 2. So that would be an eighth plus, I'm going to get a computer to do that for me because I didn't bring a calculator with me. Is it minus 2 or plus 2? Plus 2. So when I use my calculator, I get minus 1.375. That's what my computer tells me, which is negative. And so it doesn't really matter what the value is. I just want to know whether it's positive or negative. So I go back to my diagram, and my function value is negative here. And so therefore, because it crosses from minus to positive on this side, I will choose this as my next interval. So next interval is from 0.5 to 1. So therefore x3 is the midpoint of that, which would be 3/4. The way of figuring out the midpoint, if you're not sure, is to add them together and divide by 2. So this will be 0.75. Okay, so there's my next interval. So my next interval's there. And then I figure out the midpoint, which was 0.75. Okay, so I've done that bit. So I've calculated, and now I need to go back to step 1 and calculate the function value. So f of 0.75 is, from my calculator, minus 0.545. So ish, approximately. Which is negative. So we'll go back to our diagram and we'll say negative. And so therefore, it's not this one, but this one that we're going to choose, because that's the one where it goes from negative to positive. And so my next interval is from 0.75 to 1. And then the midpoint of that, so therefore x4, which is the midpoint, would be halfway from there to there. 0.875, which is this point here. Now, I haven't been asked to go any further, so I stopped there. I found x4 because the exam question itself asked me to find x4. Let me just check that I've gone to the right spot. Find x4. Okay, so that's what I've done. So if you had to go any further, I would then start drawing a new diagram for that last little bit because I've run out of space, so I'll make that bigger and continue from there. You don't have to draw the graph. So good question. You don't have to draw the graph, it just helps me make the decision. So in your exam, it's okay to just have that. Well, just have that. Okay, so none of this is necessary for the exam, but it does mean that it's easy for me to do. So you could draw this on your scribble paper. So you get given your exam paper and you get given scrap paper. So you could draw this diagram on your scrap paper rather than putting it on your actual exam, and you'll have enough space. So yes. So do note that sometimes this one, it just kept going further and further this way. If at this stage that had become positive there, I would have chosen this as my interval and done 0.25. Okay, so on each section you have to decide where your new interval is. And that's good advice for any procedure, to try and write down the steps so that you can keep track. And so in each of these I've done all 3 steps. So that's the bisection method. Is that all right? Cool. But yeah, you don't have to draw the graph.
So if we get the 4 times, get the following 875, we stop.
That's it, because they asked you, in the exam question, they specifically said, find x4. They specifically said, highlighted there, find x4. So that's why I stopped at x4. So they said to do it 4 times, and I think technically the first time was choosing this one here. But they did that part for us. Okay? So the first time was done by calculating these 2 and then choosing the next interval to be the only interval we've got and then finding that one. So yes, different lecturers count them as different times. Some lecturers would call that first one x0, but they've specifically said to do it this way, and so that's what I've done. Cool. Did you have one?
Yeah. Question 6 of exam 2013.
Which half? Algebra or?
Algebra, yeah. Because I went with I asked the tutor how to do it, and she wasn't quite sure how to do the Q matrix.
Is that this thing here?
Yeah.
Okay.
So we didn't think there would be that many zeros in it.
Yeah, so I'll have to look up the notes to remind myself how to do this. But that's a good plan anyway. Not that you can have your notes in the exam, but do you guys get a cheat sheet? Do you get to make a cheat sheet?
Yeah.
Okay, cool. Double-sided? Excellent. So that's anything that you can't remember on your own goes on there.
Yeah.
Okay, so let's just have a look at the question. An esky body is made from a box and 2 handles. To make an esky, a lid is secured to the esky body by 2 hinges. If an order y and gross projection vector x are given by those, find the appropriate parts listing matrix Q and a production vector x such that I minus Q times x is y. Okay, so I'm just going to draw a picture for myself so that I can understand the question, and then we'll go and have a look at this part of the note.
I attempted it, but I didn't know if it was right.
All right, well, let's see if I get to the same place. Because people are going to watch this and it might be good for them to see how you could muddle it through even if you weren't sure. So I have an esky body is made from a box and 2 handles. Okay, and then to make an esky, a lid is secured to the esky body with 2 hinges. So to make the actual esky, I use the body and a lid and hinges times 2, yeah? Okay. Okay. And then they're saying you've got eskies, bodies, boxes, handles, lids, hinges. Okay, so let's see if we can have a quick look at the notes for this part of the course. Now this is in algebra somewhere, and it's before your optimisation. Or I might have to steal your notes because it doesn't seem to be in the short notes.
No, that's what I thought. When I went through with my lecturer, she said that I don't think there was any notes. I'm not quite sure, but she didn't know how to do it.
Yeah, so
And it wasn't in the. We haven't done anything similar.
so I have a feeling that this might not be in the course anymore.
Because it's been in every single
Past exam. So if you went through it with your lecturer and she didn't know it.
No, my tutor.
Oh,
I
okay.
haven't gone through his lecture yet.
We'll have to have a chat, but I think my understanding of how this works is this, just in case. But I think it's not in the course anymore. And IFM has a tendency for something to change every semester. So let's see. But this is my description of how things work. And then it's like just your input-output thing with the Leontief model. It's similar to that. Okay? So
it's all add up to one.
not necessarily this time, but I'm just going to have a look at this, because this is that I minus q x equals y is similar to the Leontief model, right? Okay, so for your Leontief model, I know this is small, so we'll try and zoom in. For your Leontief model, you get a production vector and a demand vector and an input-output matrix. And then the matrix tells you how many of a particular other industry is needed to produce one output of my industry. Is that right?
Yeah, so I just put all the elements on sides and then add them up. If that makes any sense.
Mm-hmm.
So I'll put all my columns and rows, SKs, bodies, boxes, handles, lids, hinges, and then same on the other side. And then every time on the column of bodies, I write down what it needs.
Yeah, and I think that's a good plan.
But then for the handles and the lids and the hinges, they'll all be zeros.
Yeah, I reckon that's how it goes. So it was eskies, bodies,
Boxes. Yeah.
boxes, handles, lids, and hinges, yeah?
Yeah.
And then we're supposed to multiply it by... So the order is... Okay. I just want to make sure I understand how this works. So normally, in the notes, it's like I minus AX equals D. So that Y would correspond to the D that we normally have.
Yeah.
Okay. And so when you do this, to produce one esky,
It needs one lid.
it needs one lid and two hinges.
Yeah.
Does it go this way or this way?
I think I did it when it goes down.
That would make sense. I'm just going to read this carefully.
Yeah.
The value of the output of industry I needed by all n industries to produce the output specified by the vector x. So to produce the output x. Yeah, okay. So to produce... Sorry?
For the closed, you always go down.
Yeah.
Yeah. So that's up.
Yeah, you've got to understand that for most of these things, this is really something that most of us don't know. So, but yeah, it looks like we go down. And so to make an esky, we don't need an esky already.
Yeah.
We need a bod. We need a body. Which one is the box and which one's...
Esky's a lid and two hinges.
So we need... No, you need a body as well.
Do you?
Because back on my diagram,
Yep.
it says a lid is secured to the esky body back here.
The esky body, so that's body as well.
So you need the body as well.
Yep.
So we need a body and a lid,
Yep.
and this was a handle here,
Yeah.
this is hinges, and two hinges. So that's what we need to make an esky.
Yeah.
And then to make
Body.
a body, we needed a box and two handles. And to make a box, well, that's not, we don't, that's, yeah, we don't need anything for that, because that's a basic thing. So the rest of them should be zeros.
Ooh, because all boxes I put in a 2 to the handles, the hinges. Or that's wrong.
Yeah, well, this is why I drew my diagram.
Okay.
We were told a body needs a box and two handles to make a body. And so the box doesn't have anything to build it from.
Oh, okay, yeah.
And so that all the rest of them are basic things that are that are used to build other stuff, so the rest of them will be 0.
And then from there you'd obviously go to find out what x is, you just go to inverse. So I minus
Yeah.
q inverse times by y.
Yeah.
Okay.
Yeah, so this is my q. And then, yes, exactly, we'll go I minus q. And the idea is that you need
They give you y.
they give you y, yes. So you know that the total amount you produce has to be the amount that's used up by producing x, and then you have to have left over the y that's left over. And so that's where that equation comes from, because this is ix here. So ix minus qx is y, and so therefore I minus qx is y. And so we can do find the inverse of that and multiply it on both sides, like that. Yep. Awesome. So I would now have to go I minus this. So it's very similar to your Leontief models, except that the construction of the matrix is based on slightly different information.
Yeah.
But after that point, it's the same, and you still go down the columns. Okay. And so that's a very big matrix to attempt to invert. You could also do it by row operations, I guess, if you wanted.
Yeah.
So the alternative, so you've got that method, or you could do, your I minus q and stick the y next to it and do row operations, and that could work too. And that would probably be particularly effective for this because most of the entries are 0. So, so the I minus q would be 1, 2, 3, 4, 5. Minus 1, 0, 0, minus 1, minus 2, 1, minus 1, minus 2, 0, 0, 0, 1. Like that. And then we'd have to find the inverse of that by whatever methods we have for finding inverses. If you've got a graphics calculator, you could ask it. Or alternatively, yep.
Will we exam? Do we need to show the inverse of that? Or just put
I think because they let you have a calculator, you're allowed to just do it and not show the working. Unless they specifically ask you to show the row operations, then you're allowed to use a calculator to do it. But I don't have a graphics calculator, so I would have to do it by other methods. So I'd be putting my y in, which was 356, 0, 16, 2, 4. Like that, and I'd have to do row operations. I've already got that the first one is 300, and then I can do it would only take a couple of row operations to finish that off. So I could do row 2 is row 2 plus row 1, and row 5 is row 5 plus row 1, and row 6 is row 6 minus 2 of row 1. But it's going to be fairly complicated, so probably doing the inverse is the quickest way. You know, or use the calculator. Which is really nasty of them, actually, to get you to invert such a gigantic matrix. Because even putting it into your calculator is going to take quite a bit of time. Yeah, because doing those row. No, that's okay. That's actually going to work pretty quickly because of where the zeros are. So I'm going to get 0, 0, 0, 0, 0, 300. And I'm going to have to add them, so it's 356 now. Didn't change that one. Didn't change that one. I did add on to this one. And I added on 2 to this one. So this would be 601. And then I could do row 3 is row 3 plus row 2. And row 4 is row 4 plus 2 of row 2. Two lots of 356, 600, 712, so we've got 728. And that's my production vector X. There. So it had a lot of zeros in convenient places. So I'm going to have to produce that total amount of production in order to have enough left over to satisfy that demand. Cool, I don't like not finishing a question. I should write down on top of this so that I don't forget that this was 2013
Question 6.
algebra algebra question 6, wasn't it?
Yeah.
Okay. Cool. Now the other one I did, what was the other one I did again? That was 2012, wasn't it? Calculus question 4. Just so that people can go and look up the appropriate exam. What I'll actually do is I'll copy the page from the exam it came from and put it in when I put it online, so that it's easy to note. Okay, so any other questions? I am able to go over whole topics if you're interested in that too, but other than that, you go on.
Function question 6.
So function question 6 in which exam?
Yeah. 12.
2012, so the same one we had before.
Yeah.
And we want to go down to question 6. This one here. Okay. Question 6. For an interest rate of 8% per annum, for an interest rate of 8% per annum compounded quarterly, find the equivalent rate I per annum compounded 2 monthly and the equivalent rate J compounded annually. So we've got 2 things to find out. We have to figure out the rate per annum compounded every second month, and the rate per annum, and the rate per annum. Okay, well there's a formula for that. I can often not remember it off the top of the head, but I can figure it out.
I is equal to n bracket 1 plus j to the power.
Yeah, it's like on the last page of the notes.
Is it?
This thing here.
Yeah, that's one ahead.
So if you do want, so the strategies for remembering it, Of course, you've got a cheat sheet, but it's good to know how to do it anyway. But first, let me do this was 2012 calculus question 6, wasn't it? Or functions, you know. I'm so used to Maths 1A and Maths 1B and Maths 1M that have calculus and algebra. So, okay. So, just to be sure, this is the information we had 8% compounded quarterly, and we want I% compounded 2 monthly, and J% compounded annually. Okay, so we have to know how many times per year it is. So this is 4 per year. This would be 6 per year. And this would be 1 per year. Okay. So the reasoning behind it is to imagine what would happen if you put a principal into your investment, or you had a loan in your loan, but put a principal into an investment and allowed it to compound for the same amount of time, and then you can compare them. So usually you compound it for a whole year. So if I had a principal, if I had a certain amount and I allowed it to compound for a whole year at this one, then the amount that I would have at the end would be 1 plus 8% divided by 4 to the power of 4, because that's the normal formula for doing compound interest. It's approximately, it's 0.08 per annum for the whole year, so I divide that by 4 for the single quarter, and then I'm going to have to compound 4 times, which means making it that little bit bigger 4 times. And I want to know what interest rate would happen if I did the same trick but compounded 2 monthly. In that case, I'd have 6 per year and I'd get that. So this is how I would figure it out. So I don't need the p's because these are equal to each other and the p's cancel. So it doesn't matter what I put in, it's this part that's going to be telling me what the I is. So that's how I remember it, because it means I only have to remember the compound interest formula. And then I have to solve this for I. So I'm just going to tell the reader what I'm doing, find I. So I can cancel out the p's, I don't need them, so I need the I all on its own. So the first thing I'm going to do is go as far away from the I as I can, which would be this power of 6, and I need to get rid of that power, which means doing a power of a 6th on both sides. So currently this was a 6. If I do it all to the power of a 6th, 6 to the power of a 6th would give me a 1, and 4 to the power of a 6th, I times the powers and I end up with that. And then I can subtract the 1, like that, and I'll get I on 6, and then I can times by 6. So, and then I'll get the I on its own. Like that. So this formula in your notes is exactly that. That's that formula there. It's just that my I is the I I'm looking for, and the J is the 8%. And the M is the number that went with the J, which was 4, and the N was 6. So you can write that formula down direct if you like, and you would have slightly less working overall. So I'll do the other one directly with the formula rather than doing it the long way. So we have to chuck this into a calculator. So, not that I have a calculator, but I do have Excel. So we have 6 times 1 plus 0.08 divided by 4, all to the power of 4 on 6. Well, 4 on 6 in brackets, minus 1. So it's 0.079376 according to my calculator. So I is 0.079736. So my rate is approximately 7.97%. Okay, that's how you do that one. If I wanted to find J, I could do it directly. By the same method, but I could just use the formula direct this time. So I could say, so using the formula, according to this rule here, I've got the 1 plus 0.08 on 4. That's the same as it was before. To the 4 on something. And the number of compounds per year in the new one is 1. So I just get that. So J is the compounded annually. Okay, so what I've done is I've used the same formula and notice where the changes are. Note that this is where the number of compounds per year is in the formula. And I put the same things here, like that. So that the compounds per year for J, because it was annually, is 1. So I can chuck that into my computer and change this 6 to a 1 and get 0.08243. So the rate is approximately 8.24%. Yep.
So this one is also the compounding, and we will use that to calculate the value we have still to compound over the period, right? The interest rate, because this is also the compounding rate. So like what we do in
I'm not sure. Just give me a second. I'm going to just write down this again so that I can understand your question. I'm just going to write down what we've got. Is that okay? So, so we're saying that 8% compounded quarterly is equivalent to 7.97% per annum compounded 2 monthly. And it's also 8.24% compounded annually. That's what we've been told. So I don't have to worry about any money that I might invest yet, because they didn't tell me that at the moment. They just asked me to directly calculate what these were.
Also come to the question I was going to ask you with the functions 2011 paper.
Okay.
There's a question similar to that where you have to find out the compounding of interest, but on the bottom we've got another part where you have to actually calculate it.
All right. Give me a second. So I think, and just check with me, I think this is the question you're asking. I'm not sure. I'm just going to say a couple of things and hopefully that one of them will work. That percentage is taking into account how often it's compounding, but that's not the percentage per 2 months, it's the percentage per annum. So the idea is if you were given normally when you're given one of these problems, you say if you've got like $2,000 and it's compounded, and it's in compound interest for 6 years, and it's 5% per annum compounded every 2 months, and then you have to convert that 5% per annum into per 2 months percent by dividing it by 6. So this is that original 5% that you would need in order to get the same amount. So I don't have to do anything else to finish part A of this question because they've just simply asked me, they've just simply asked me to find the new rate that I would use to get the same amount of money. And this is how they do comparison rates on telly, or with other things as well. So does that answer the question or not? Okay, good. Okay, so you were saying in 2011, was it?
Question 5. Function.
Okay.
And that was, yeah.
So 2011 functions, question 5. Okay. So this question says, show all the steps in your working. So for an interest rate of 4% per annum compounded monthly, find the equivalent rate I per annum if interest is compounded 6 monthly and if interest is compounded continually. Okay. So we had 4% compounded monthly, so 12 per year. Okay. And then we want I% compounded 6 monthly, which is 2 per year. Okay, so we can use that formula direct if we want to. So we can say, well, using the formula, we'd start with what we would normally use for this one, which would be 1 plus 0.04 divided by 12 to the power of 12. That's what we'd start with. And then we'd have to do that to the half, to the 1 over that power, so we'd have to divide by 2. And then we'd subtract 1, and then we'd times by the 2. And these two numbers here come from there. Okay, so that's my I. And then I just ask my computer for that. Two. 1 plus 0.04 divided by 12 all to the power of 6 minus 1. .04035. Really? Just check if I've done that right. 1 plus 0.0, it was 4%, wasn't it?
4.033.
Yeah, that's what I got. Okay. So I get 0.040335. So we've got that the rate is approximately 4.033%. Okay. So for part B, so part II, it asks, what's the equivalent rate compounding continuously? Now, as far as I know, your notes don't have a direct formula for that, do they?
I think so.
My summary ones don't, like the ones that these are the summary notes. I didn't get the full notes.
Oh, okay.
But I can figure it out anyway by the same method I figured out the others. So I can say, well, I need to know if I compounded them both for a year, how long, what would I have? And I want it to come out to the same amount. So I could know that if I compounded the original one for a year, it would be 1.004 over 12 to the power of 12. That's what I would use to calculate it if I did the original one for a year. And then when you do compounding continuously, it's p e to the rate times the time, and the time is a year. So that means that I can cancel out those. We don't know what that 0.04 is though. We want to know what that is. That's my I%. So that's the rate there. And so I have to figure out what I is, and that's good. So the 1 doesn't matter, and even if it was a different number, I need to get rid of the e to the power of first, and to get rid of an e to the power of, I do ln. So ln of e to the I would just be I, and ln of all of this would give me the answer for I. So in my computer, .0399. Whoa. So make sure you put your brackets in the right spot when you do it in a calculator. And so I get my rate is approximately 3.993%. You would expect anything with a higher, anything that's compounded more often would have an equivalent lower interest rate. So it's good to know that. And so you'll see that it was 4%, and then we compounded less often, and so that had a higher interest rate. And then we had, it was 4%, and we compounded it more often because we compounded it continuously, and it came out to lower. So this is the lowest possible equivalent rate because that's continuous compounding. Okay, so the next part of the question was the one that we were actually hoping to get to. So we'll just go back and have a look at that. How much money must be deposited now to provide a perpetuity with payments of $20,000 in each of 3 months? Okay, so that's a completely different thing now, isn't it?
Yeah, that's why.
Yeah.
And then and you have to start the payments in 3 months' time.
Yeah.
So that's what we got confused with as well, because we don't know if that's in the course or anything anymore.
All right, but we'll figure that out. So that's not directly related to Part A at all.
Yeah.
Okay, but Part A of that and Part A of the one we had before were both about converting interest rates, so I might keep them in their own thing and start a new page for when I put this online. Okay, so now we've got perpetuities. Oh, okay. Let's give that a go. So, document camera. So this was still, what year was this, 2011?
Yeah.
Functions, question 5B. Okay, so it says, how much money to be deposited now? So, to produce a perpetuity with payments of $20,000 each every 3 months, with the interest rate is 8% per annum compounded 3 monthly. 8% per annum compounded 3 monthly. Okay, so let me just think this through. They're asking for the present value of the perpetuity, That's what they're asking for?
Yeah.
Yeah. So, i.e. the present value. So that was just a roundabout way of asking for the present value. And so we've got part A, we start in 3 months' time, and part B, we start now. Well, in 3 months' time would be the ordinary kind, because the perpetuity normally is paid at the end of a period. Yeah? Is that right? So we'll just...
If it doesn't say beginning, then we'll just automatically assume that it will be end, right?
Yeah. I'm just going to check that, but I'm pretty sure that they're always paid at the end of a period because of how the formula works. So I just want to check something. Well, let me just think. If I just put it, if I just had if I had an ordinary annuity that only went for one period, right? Then, according to the ordinary annuities formula, which is here, if it only went for one period, n would be 1. I've got 1 plus I to the 1. So if n is 1, I'd get 1 plus I to the 1 minus 1 over I. So 1 plus I to the 1 is just 1 plus I. We take the 1s, we divide by 1, and we just get a 1, and you end up with just the payment. So yes, it's at the end. Payments are at the end in an ordinary one if they don't specify. Okay, so... So, just before we get to A, we know that since they didn't say, that means that payments are at the end of period. Okay, so that means that so if you start now, then that's an ordinary one, right? Like, that's really difficult to interpret what that means, isn't it? Well, if you do have something that you feel is ambiguous in an exam, you should write down what you think it means, and then they'll hopefully just give you the full marks anyway, because they'll realise that their question was ambiguous.
Yeah.
So I'm just thinking that
Starting now would just be paid at time
one,
end of time 1.
time 1, yes,
So time 1.
yeah,
And then 3 months time would just be.
yeah. So we're going to assume that it means that starting now means the first payment's in 3 months' time. Okay? Is that what you're saying?
Yeah.
Hmm. Okay, let's assume that start in 3 months' time means the first payment is at the end of the first 3 months. Let's assume that that's what it is. So if you're not sure what they mean, write down what you mean, and you can get the answer. So if we assume that,
Yeah, for the first 3 months.
yeah, and that means it's an ordinary everyday perpetuity, and the ordinary everyday perpetuity formula will work because perpetuities are generally assumed to be at the end of periods, and so therefore, according to this, it will be R on I. On the per period interest rate, isn't it?
Yeah. So you go
So-
0 to 8 right?
Per period rate, yep. So it'll be 20,000 divided by the 0.08 divided by 4 because there's 4 lots of 3 months per year. Okay, so that's 4 per year. And so that will come out to whatever it comes out to. 20,000 divided by 0.02 would make it even bigger. $1 million, apparently. That's what I get. One, two, three, yep. Okay. That's what I'm going to assume. If I assume that starting 3 months' time means that the first payment's at the end of the second period, then that would be different. So I'm going to assume that start now means the first payment is now, right? So wouldn't it just be that plus 20,000? Because the present value of a payment right now is whatever the payment is worth right now. So that would mean that my present value would be the perpetuity itself plus that 20,000 for the first payment, which would be 1,020,000. That's how I would do it. If your assumptions are different, then your calculation would have to be different. So if they were asking, if start now meant that the first payment was in 3 months' time, then that would mean it would be $1 million. And if start in 3 months' time means that the first payment's actually 3 months after that, and then we'd have to discount we would have to do a discount, so we'd have to divide by 1 plus 0.08 over 3 over 4 to come back to current purposes. So I just want to, just in case, I just want to put that possibility in now. So what if the first payment is in 2 periods' time? Okay, so as in we have this is now, this is 3 months, and this is 6 months, and that's my first payment there. Okay? Well, in that case, this bit would be my perpetuity, my ordinary perpetuity, that bit there, and it would have a present value at 3 months of $1 million. Okay, so present value in 3 months' time of the perpetuity would be my R on I, which would be my 20,000. That's 200,000. 20,000 on 0.08 divided by 4, which was my $1 million. And then I have to discount that because that's still in the future, right? And so the actual present value would be this present value discounted. Is that how you do it? Yeah, you divide by that, because if I was doing a future value, I'd multiply by this. Yeah, so my 0.08 over 4 to the 1. Yeah. Yeah, and so my answer is 980,392. Approximately. Probably not worth to do it, to nearest dollar. So that would, just so that we know how to do that, and I have no idea which of them that exam writer actually wanted, so if you're not sure, just write down what you assume they mean, and then hopefully they'll give you all the marks anyway, because the person marking it will go, oh yeah, it is ambiguous, okay. That's just some good exam strategy for you. You want to talk about anything else?
Also, there was another question that I got wrong in the tube. It was tutorial 9, I think. Algebra.
Let's go looking for that. They really should label these things. Oh, look at that. So, is it the one with convex sets and optimization problems?
Yeah.
Okay.
Yeah, scroll down. And it was, it was question 4.
The one with this bakery?
Yeah. I didn't understand, I looked at the answers, I just didn't understand with the pastry.
Yeah.
There's a minimum and a maximum, and they hand out 2 constraints for it. Yeah, I didn't plot it down in my thing, so I missed out on a couple of 2 verses, I think.
I mean, I did this one with people for days in the Maths Learning Centre, so I can probably bring back it to memory, but I can also just do it from scratch because I know that people do appreciate knowing how to do this. Okay, so I'm going to have to keep switching back and forth between the document camera and the screen or it won't record both, so I apologise. So I'll just read this. A bakery makes 2 kinds of pies, apple pie and cherry pie. One apple pie requires that, one cherry pie requires that stuff. Fruit supply can supply these things. Bakery makes its own pastry. The bakery does not want to waste any pastry. The supply of spice is unlimited. Okay. So we've got all this stuff, and we need to try and interpret what that information means. Do you know what I'm going to do? I'm going to print this and be back in 2 seconds, okay? So, give me a second, I'll pause the video for a moment. Okay, so I've got it now. So this is the question, and we just need to pick out the most important information, and it's easier to be able to draw on the question to be able to do that. So the first thing we need to do is try and figure out what stuff is the aim for us to find. Okay, and so I'm going to ignore the A, B, C, and D and just pretend it's just to solve the question thing. And look at this bit here and look at question D first. You should always look at the overall outcome first so that you can decide. So what's the maximum possible profit? We'll do that now. How many of each type of pie should be made in order to achieve the maximum profit? So that's what we're interested in. How many of each type of pie?
There'll just be number of, right?
Yep, and so those should be my variables, like my X and my Y. I'm the sort of person who will label them so that I can remember what they stand for. So I'll usually say something like, so this was Tute 9, wasn't it? Algebra. So let X A be the number of apple pies made, and XC be the number of cherry pies made. Because then I'll remember what they stand for. Okay, so that was from this bit here. And then I can go back and do the rest of the question. Okay, so I'm going to make a table of all the information I've got, okay, based on how many of each things. So here we go. We have the pies themselves, apple and cherry. And I've got the number made is XA and XC. So the first piece of information we've been given is that an apple pie requires 0.3 kilograms of pastry. So pastry needed per pie. That's the first piece of information I've been given. So the apple pie requires 0.3 of pastry, and the cherry pie, we haven't been told about that yet, but presumably it gets there. So cherry pie requires 0.3 of pastry as well. Okay, and the next piece of information is the apples needed per pie. So the apples needed per pie is 0.5 kilograms of apples for the apple pie and none for the cherry pie, right? And the cherries needed per pie. So for the apple pie, they don't need any cherries, and the cherry pies need 0.1 kilograms of cherries. Okay, doing well. And spice needed. I don't know if this is going to be important yet, so I'm just putting it all in. So the apple pie needs 0.001 kilograms of spice, and the cherry doesn't need any. Okay. Awesome. Alright, the fruit supply can provide up to 8 kilograms of cherries. So if I can figure out the total amount of cherries that I actually used overall, I might just sit down, then I can talk about that constraint. Okay, so total apples needed. So let's just think about it. This is how many apples that we actually need, and this is how many we make. So every one of these is going to need 0.5, so I have to times them together to get the total amount needed for the apple pies. So I need 0.3 lots of XA, and this one will be 0 lots of XC, so just 0. And the total apples we need, my fruit supply is not going to be able to give me any more than 8 kilograms, and so this together has to be less than 8. Or equal to 8. And my total cherries, my apples don't have any cherries, and my cherries have 0.1, and they can't, 8 was the cherries, sorry. The 20 kilos was the apples, and 8 was the cherries, and so we get that. Okay, and so there's a couple of constraints. The bakery makes its own pastry and will make a minimum of 12 kilos and a maximum of 30 kilos. Okay, so okay, so total pastry needed. So total pastry needed per pie, so I've got 0.3 of XA and 0.3 of XC, so that's the total amount of pastry. And the bakery makes its own pastry, make a maximum of 30 kilograms, so it can't. Alright, so we'll just pop that in. This is less than or equal to 30 and greater than or equal to 12. Yeah? The bakery does not want to waste any pastry. Well, that would mean that since the bakery has to make at least 12, we have to make at least 12, we have to use at least 12. So that not wasting any is telling me the greater than or equal to 12. Because otherwise, if you're allowed to waste pastry, then the minimum amount of pastry is irrelevant.
Yeah.
Yeah? So we can just say if...
Greater than 2 or greater than 4?
we would ignore it completely. If allowed to waste pastry, then it doesn't matter what the minimum is, right? Because you just, so say today you only make one pie, you'll just chuck out most of the pastry. And so the fact that you've made 12 is irrelevant. Does that make sense? Yeah. So we're allowed to wait. If you're allowed to waste pastry, the minimum used is irrelevant. But not allowed to waste. So must use at least 12. And so we've got another equation that says that the amount of pastry used has to be greater than or equal to 12 as well. That took me ages to figure out when I read it the first time. Yeah, so if you were allowed to waste pastry, then that minimum amount doesn't matter. You'd ignore that completely. Okay? Okay, so this is the reason why I'm going to use that. And then the next thing it says, it's a supply of spice is unlimited. Okay, so I don't have to worry about the total spice at all. That was a red herring. Okay, and then finally in my table there's one more row to do, which is the profit per pie. There's two more rows technically. So the profit per pie for an apple pie was 2, and the profit for a cherry pie was $1.50. And so therefore the total profit is 2 for every one pie, so that's 2xa, and $1.50 for every cherry pie, so that's $1.50xc, and that's my total profit there. And so now I've got some constraints. I've got that, and both of them, they're my constraints. And my objective function that I'm trying to maximize is this. Right. So if the question in the exam had asked me to formulate it as a mathematical problem and not solve it, my final statement would be that, but I'd probably write it down again so that the reader could find it. So I would say we want to maximize profit, which is 2xa plus $1.50xc, subject to 0.3xa is less than or equal to 20, 0.1xc is less than or equal to 8, 0.3xa plus 0.3xc is less than or equal to 30, and 0.3xa plus 0.3xc is greater than or equal to 12, and also xa and xc are greater than or equal to 0. And so that would be the linear program. But to actually finish the problem itself, yeah, we could do this one graphically actually. So you've been taught 3 approaches to this sort of thing. You've been taught how to do it graphically, you've been taught how to do it using slack variables, and you've been taught how to do it using the simplex method. You've been taught 3 methods for solving it once you get to this stage. The simplex method is the one where you include the function itself as one of the rows.
Yeah, and then you put as slack variables, you put z.
You still put the slack variables in, but yeah, you give it a z for that, and then you go, well, let's find the pivot column and the pivot row, and then by doing all of that.
That reminds me, I've got another question in regards to that. I forgot which one I was doing. I've got so many.
While you're looking, I am just going to finish this because. So what I would actually do to do this graphically is I would draw my graph, and you pick one to be the x-axis and one to be the y-axis, and then you would have to draw all of those lines, and they would need to be labelled so that you could see where they were. So I could draw this one here. So if I label them all, I can start calculating them in a way that makes sense. So XA would have to be 20 divided by 0.3, which would be something annoying. So this one would be probably easier with slack variables. So XA is 20 divided by 0.3. So 20 divided by 0.1 would be 200. 200 divided by 3 would be 60.6. And this one would be XC is 80. Yeah. So what you do is you make them equal and you find the places where they do that. So this is my 66.6 and this is my 80. So that's line 1 and that's line 2. Line 3 is 0.38 plus 0.3c is less than or equal to 30. And so that crosses at 300 on both of those axes, so I didn't make my picture big enough. No, 100. No, it is big enough. So this was 80, this was 66.6, well, 7. 100 is sort of here and here. So I have line number 3, and line number 4 is greater than or equal to 12, so it'll be 120 divided by 3, which is 40, so we'll have one down here as well. So that's line 4. And then you have to figure out where the feasible region is within that. I'm not entirely sure which side of that point this line crosses, but I'm presuming that this... No, it's where it is. And so I need to figure out where inside that region I'm supposed to be, and I find it easier to draw a second diagram on my scrap paper to do that. So I'm going to run through each of those and I'm going to just see if the origin is part of it. I'm going to cross out the bit I don't want. So this is how I do it. I go when... So I can look at a point that's not on one of the lines, so the origin's a really good point. So that 0, 0, if I sub 0, 0 into this formula, it's correct, because 0 is less than or equal to 20, and so 0 is on the correct side of line number 1, so I'll cross out the wrong side. And then I'll sub 0, 0 into next line, and that is also correct. So that's 0, 0 is on the correct side of this line, so I'll cross out the wrong side, because 0, 0 is down below, so the other side must be where it's wrong. And then in the next line, 0, 0 is less than or equal to 30, so in line number 3, 0, 0 is on the correct side, so I'll cross out the wrong side. And then finally for the last equation, 0, 0, if I put that in there, it's not more than 12, so 0, 0 is on the wrong side, so I'll cross out the side that 0, 0 is on. And I know that the x's are not allowed to be negative, so I'm left with this zone here. So this would go on my scrap paper somewhere. And then my actual feasible region is this bit here. Like that. So that is how I figure out where the feasible region is. And if I was doing it fully graphically, I would draw a line of this slope, and I would move it up and down and find the last point that it hits. So I could choose, what's 2 times 1.5? 3. So, no. Yeah, 3. So I could choose a line that goes through, if I pick one of these, that's 80 there. So if this is equal to 80, so just a second, if this is the y here, the slope will be minus 2 on 1.5. So, which would be 4/3. So for every 3 across it goes down 4. So it'll go across like, across 60 and down 80. So it'll be sort of this slope of the line. And so the last point that's going to hit as I move it up to get higher profit will be that point there. So that's where the highest profit is. So that's how you can do it graphically. Otherwise, you can just figure out what all of these points are and sub them all in. So I would often give them names like A, B, C, D, E, and then write them down. So I'd go A, B, C, D, E, F. A is the point 40, 0. I think that's right. So, yeah. And B is the point 66 and a third, 0. And C is the point 66.7. And something for Y. And so I know that if I put in my x into the formula for this line number 3, I'll get whatever I get. 3 times that was 200, divided by 10 was 20, and so I'll get 10 for that. So a third, so 100 divided by 3, so 33.3. No, that doesn't seem right. I need to figure out what that point is, and then D will have its own thing, and it will be something 80, and then E will be 80, 0, 80, and then F will be 0, 40, and then I will sub all of them into the profit, and whichever one gives me the maximum profit is the maximum profit. I just need to get another piece of paper to do this properly. So 0.3 times 66.7 plus 0.3 xc is 30, which means we get 0.3. So that times 3 would be 200, so this is 20. 0.3 xc is 10, xc, 3 xc would be 100, so xc is 33.3 apparently. So I might have drawn my diagram wrong, because this point's actually like way down here.
I think the point was 40, 60.
I might have done my calculations wrong.
I didn't get the, mine was wrong. I didn't get the other one there.
The solutions are here.
Yeah, solutions.
I get 33.3.
Yeah.
So this is actually way lower than it looks. So I've drawn my diagram a little bit dodgily. And then over here at 80, that's meeting line 3 as well. So I've got 0.3 xa plus 0.3 times 80 is 30. Which would be 24. So 0.3 xa is 6. And then 3 xa is 60, so xa is 20. Right. So that's how, any point that's in the middle here somewhere, you're going to need to work hard to figure out what the matching actual coordinates are. Yes. So this would be finding point C and finding point D. And if there's 2 sloping lines, you're going to have to use your ordinary method of trying to find where 2 lines meet to get that point in the middle. And so now we'll sub all points into P equals 2xa plus $1.50 xc to find the maximum. So that's how you would do that. Okay, did you find that other question?
Yeah.
Got a few minutes to go. No, I've got a couple of minutes.
Quick. Well, I just wanted to show what. I just wanted to quickly show you what I did and see what I did wrong, because that's how I can do that.
Which one are we doing?
Question 4.
Which one's this from?
The second one was 2012. But, yeah. But yeah, so I think I got this right. Like,
Okay.
Yeah. what I did wrong.
Yeah, sometimes it's easier to just do it myself
Yeah,
to check it.
sure.
And since we're recording it, it's easier to, other people might be interested.
Yeah,
So what was, what,
Algebra, 2000 exam, 2012, question 4.
Oh, don't do you know that?
so you guys doing okay? Did you have anything in particular?
Yeah, last question about
Like, that's the wrong one.
Looks like the wrong one.
No, that's the wrong one.
This is 2012.
Yeah, scroll. Is there any bisection? That's the one.
Okay, now what were you guys asking?
yeah, it's about the past exam.
Yeah,
To be no, the first one.
2012 was
The question also 1B and 2B.
which algebra or
Function.
okay. So I can go over, so I'll do both.
Just do the function, not just.
This one,
Yeah, 2B.
1B.
2B.
1B and 2B.
Oh, yeah, 1B and 2B.
1B and 2B. Yep. Okay. All right. So we'll do that one first. So this is 2012 functions, question 1B. So the question says, sketch the graph of a cubic polynomial ax cubed plus bx squared plus cx plus d, which has zeros at x equals -2, x equals 1, and x equals 3, with a less than 0. Okay? So we've got that ax cubed plus bx squared plus cx plus d. That's my function. Call it px. It's a polynomial. And we've got zeros at x equals -2, 1, and 3. And a is less than 0. Okay. So they're not actually asking us to find what a, b, c, and d are.
Yeah.
They're just asking us to sketch it. So the zeros tell me where it crosses the x-axis, so that's a good start. So we have 1 and 3 and -2. So it crosses the x-axis at those places. Have I got that right? Yeah.
I think we could go. So we just check the answer.
Okay. So the zeros is telling me specifically which, because it's telling me x equals, it's telling me where it crosses the x-axis. That's not telling me, yeah, because some people might have done it as 2 minus 1 minus 3, but that would be if they told you what the factors were.
Yeah.
And then the only other information I've got is that a is less than 0. So I need to know what shape a cubic normally is, and a cubic is normally this shape or this shape, and this would be if the leading coefficient was positive.
Yeah.
A is positive, and this would be if a is negative. So it's this one that we're interested in, and so it must do something like that, right? Technically, because these are closer together than that, it actually is pointier here, but it doesn't matter. That's a skill that you haven't been taught in particular, but yes, the symmetry point will actually be just here because of where the zeros are. Okay, and so what about question, you said 2b as well? So 2012 functions, question 2b. Let's go have a look at that one. So this question is all about limits, apparently. So by calculating the values of the function close to the limit, estimate that limit. Okay. So you haven't been given methods for calculating limits with x's in the powers. In Maths 1b and in other calculus courses, they learn how a thing called L'Hopital's rule, which is extremely useful. And so I know that the limit is going to be ln5, but that's just something that I happen to know.
We just want to know when is the function is D on E.
So when doesn't it exist?
Yeah.
So you're looking for these things?
I just confirm about if x approach to the 0 and x is 0 is not easy.
That's because the numerator is 0 as well. So look at this. So the question for those who are listening online was, how do we know whether that limit exists or not? Okay, so you said, well, because x goes to 0 on the denominator, you're thinking it doesn't exist, but that rule only applies if the top isn't a 0. Okay, so you need both. So I know that if the limit as x goes to 0 of the numerator is not 0, and the limit as x goes to 0 of the denominator is 0, then that means that the limit as x goes to 0 of the numerator on the denominator doesn't exist. Okay? But that rule only applies if the top isn't 0. And so in our situation, but the limit as x goes to 0 of my numerator is 0, and the limit as x goes to 0 of my denominator is also 0. So since they're both 0, I have no clue whether it exists or not from that information. So that's saying we do not know whether it exists or not. Okay? So if you do see a 0 divided by 0, it's an indicator that you need to do a bit more work to try and figure out what the limit is. Okay, so up in question 1a, up in part A, this one here, for example, when x is 4, the top is 0, and the bottom is also 0, and so therefore I don't know whether that limit exists or not. And it means that what I should be trying to do is factorise the top so that I can cancel something out. And in this one, when x is 3, the top is 0. That's the bottom is 0. And when x is 3, the top is 9 minus 6 plus 1, which isn't 0. And so since the top is not 0 and the bottom is, the limit doesn't exist. Okay, so it's not only about the bottom, it's about the numerator and the denominator. If they're both 0, then you don't know without doing more work.
So
but if
just visualize sentences about denominator later.
yeah, so but if they are both 0, you can usually do more work to figure out what it is. Okay, so if I actually go back to question 1, if I actually go back to question 1a, the limit as x approaches 0 of x squared minus 4x over x minus 4. So I have the limit as x goes to 0 of x squared minus, 4 wasn't it? Of x squared minus 4x is 4 squared minus 4 times 4, which is 0. And the limit as x goes to 4 of x minus 4 is 4 minus 4, which is 0. So therefore this limit may or may not exist, and I can't tell yet. And so therefore I need to do some work until I do know. So the limit as x approaches. So if this one had come out to not 0, I would have stopped. So the limit as x squared minus 4x over x minus 4, that's telling me, the fact that they're both 0 is telling me that it should be possible to factorise them. And then I cancel them out and I get 4. Okay? So this is just some preliminary working there. But for part 2, the limit as x approaches, what was it? 3, was it? Of x squared minus 2x plus 1 over x minus 3. That's what we're trying to find. So find. Well, the limit at the top is 3 squared minus 2 times 3 plus 1, which is 9 minus 6, which is 3 plus 1, which is 4. And the limit as x approaches 3 of the bottom is 0. So therefore, since it's 4 divided by 0, the limit as x approaches 3 of x squared minus 2x plus 1 over x take 3 does not exist. Yep. So in this problem back here, well, that wasn't question 1a, was it? It was question 2a. This problem back here, the limit at the top and bottom are both 0, so normally that means that there should be some sort of other work I can do to convert it into one where they're not, but you haven't in this course been told strategies for dealing with that, and so we're not going to be able to do that. But what we can do is we can attempt to figure out, well, it's not hopeless, the limit might exist. When they're both 0, the limit often does exist, and so I can try and figure out what the limit actually is by attempting to use x's that are close to 0. So I can go, if x is 0.01 maybe, then 5 to the 0.01 minus 1 over 0.01 in my calculator would give me a particular answer. Oh. Oh, minus 1, sorry. That's 1. Much better. Did that wrong, didn't I? Where'd my pencil go? Yep. And so that comes out to 1.61073. And if I choose x to be a little bit closer... Oh, I already did 2 zeros already, didn't I? Sorry. If I do it with 3 zeros... 1.60956. And what did the actual exam question ask me to do? Estimate it. Oh, okay. Well, let's estimate it to like 2 or 3 decimal places. So we'll keep going until the decimal place doesn't change. So we'll try it with 0.00 with another 0. 60945.
With a question like that, it's 2 marks, so you're obviously going to input 2 different figures, right? Because otherwise we could just put like 8 zeros and then we'll find out.
And then we'll find one.
Yeah, straight away.
So it looks like it's going to be 1.609. But yeah, you could put in like 10 to the minus 8 and that would be fine too. So I mean, I'm just trying to see what it does. So I mean, in terms of writing it down on your exam, you could probably just go straight to, x equals 10 to the minus 8 and sub that in. And you should also do the negative one as well, just to make sure it comes to the same answer. So I've got, x is 0.000. minus. And see what I get when I put a negative in that spot. Just need to put some extra brackets in. 1.6094. Okay, so now it looks like to 3 decimal places the limit is 1.609. Okay, so you don't have to do all of those, and you don't have to write them all down. You only have to write down the last couple. So it is possible to, it's okay to just write down the last 2 that you do, as long as you do one from both sides. Because if they come to different, if they're not approaching the same answer, the limit doesn't exist. If this one came to 1.609 and this one came to like 3.8 or something, then the limit doesn't exist because the 2 answers are different. You need the limit from below and the limit from above to be the same answer for the limit to exist. So if you're going to do it numerically, you have to check both just in case. Which leaves this exam question. Yep. Okay. You need to go?
Yeah.
Okay, that's okay.
Are you finished with it?
I might just stop here because I've already gone over 2 hours. And look, you can always come to the Maths Learning